hello, good day to you. Let me tell you, I am so happy to be here with you again in our regular classroom for some more physiology. Today, we will be talking about carbohydrate digestion and absorption. Here, an example of a carbohydrate. Bread, starches, pasta, all sorts of kinds of carbohydrates. So delicious for you to absorb. Just thinking about it gets me salivating. That's the feed-forward response. When you think or see the food you are about to eat, your saliva begins to form in preparation for the food. Next, when the food enters your mouth, mastication, the chewing process, mechanical breakdown of the food, along with salivary amylase, which breaks down disaccharides such as amylose, pectose, and other starches inside the mouth. Delicious. Everyone say starch. Too good, too good. But there is no time. No time at all. Next, the food now moves through peristalsis, down your esophagus and into the lumen of your gut, where more digestion may occur. At this point, it is called the bolus. Everyone say bolus.
Bolus.
Oh, too good, too good, too good. It's almost like you are here with me today. But there is no time. The stomach releases more enzymes that break down the enzymes from the mouth, such as salivary amylase, and continues to grind and churn the food, mechanically and chemically digesting it until it turns into chyme. Chyme? What is chyme? Well, it's a gooey mixture that is signaled to be released to the small intestine through the enteric nervous system. Sweet, sweet, sweet. I like to imagine that it squirts in there. Now that the chyme is in the small intestine, it may continue to be digested, where most of also absorption occurs. Well, how do we start? The chyme enters the small intestine, and what's next? I am not just talking to myself, but there is no time, no time. Disaccharide enzymes break bonds into maltose, fructose, and lactose into mostly glucose and some other monosaccharides that can now be absorbed. Make note, we are still in the lumen of the small intestine, where some, if not all, of the products of carbohydrate digestion are absorbed. Yes! Now that the glucose is into the cell linings of the small intestine, it may be absorbed and transported to the rest of the body. Not all products are absorbed, however. Cellulose, pectins, gums, and fructans are unable to be absorbed,
Fermented in the gut microbiome of the large intestine.
Now that the molecules are appropriately broken down, they may be absorbed. Glucose and galactose are moved against their concentration gradients into the cell lining the intestine. To do this, our favorite sodium-potassium pump is back again. Delicious glucose. Computer. Oh. I trust that you all said glucose there at home. The intestinal lining pumps sodium into the lumen of the gut. And the sodium wants to travel back down its concentration gradient into the small intestine. And with it, co-transportation occurs of glucose and galactose with the sodium-glucose link transporter. Fructose is not left all alone, though. It too enters the interstitial fluid through GLUT2 and GLUT5 transporters. From there, the capillaries that surround the small intestine receive compounds through facilitated diffusion and are transported to the rest of the body to make ATP and be stored for later use. Say ATP! Computer. It must be a connection issue. I trust you all said ATP. Most of them are sent to skeletal muscle and adipose tissue for worker storage. So many delicious glucose molecules. Too good. I hope in our time today you have set some goals for yourself and to absorb plenty of carbohydrates. It seems, however, we are out of time in which to absorb more information. Thank you so much for being here with me today. Now, go away, be safe, close the video.